This video is going to cover over the mediator pattern. Without going too much into the complexity, the basic idea is thinking that we have one area where we're able to create a lot of coordination between different users, different contexts, different clients. If we think about the problem that the mediator pattern is trying to solve, if we had a chat room with multiple users that connect together, that message together, if we don't have a mediator, we have each user that has to call some method on every other user directly. So if we had a chat room where one user was messaging all the other users, then the idea is that user would have to call that method message to all of those users individually. What that means is we're going to have all of these different class imports. Adding another user is going to change all of this. It's going to modify all the other users that are already existing. And we all can see that the communication logic is totally scattered. There's no single place to audit or change. And we also see that there's like n-squared connections. This means that every user has to connect to every other user if we're talking about a chat room. So if we have that, we're going to end up with this complicated, overcomplicated connections that we're all creating together. And also, this means that all of the communication logic, who talks to whom, in what format, it's going to be scattered across every single user and participant instead of living into one controlled central place. The pattern overview we have, so the gang of four defines it as an object that encapsulates how a set of objects interact. The mediator promotes loose coupling by keeping objects from referring to each other explicitly. For this, it means that the peers are not talking to each other directly. They talk to some sort of central hub, which is the mediator, which controls and coordinates all the communication with each other. The peers only know about the mediator interface. They don't know about each other. They don't know each other exists. So one object absorbs the complexity so everyone else can stay fairly simple. For our demo, we have this chat room with the users that we're going to demonstrate with the mediator pattern. So at the top, we have the chat mediator interface. This is a contract that the concrete mediator must implement. The chat room sits below it. It implements that interface. This is the central hub that all of the other users are going to interact with. On the colleague side, we have the abstract base class. This is called the component, and that holds a protected reference to the mediator. The user component extends the component and inherits that reference. And if we look here, the user component has no direct reference to any other user component. Every arrow between the colleagues passes through the chat room, so the diagram makes the pattern immediately visible. First, we want to look at the chat mediator and user. So there's two interfaces in this implementation. The user interface is just a simple data shape. It has just the ID string and the name string. There's no behavior, it just defines the identity. It is used as a parameter type, so the mediator knows who's sending and who's receiving. The chat mediator interface is the more important one. It has mostly the method that we're looking for. It declares the single method that all the communication flows through. This method is the send message. And it takes the sender, the user, the receiver, the user, and the message string. Any concrete mediator must fulfill this contract. Colleagues call this method exclusively. They never call each other. Next, we're going to talk about the component. The component abstract class is an abstract colleague. Every concrete colleague will extend this class. Its job is simple. It holds a protected reference to the chat mediator. The constructor takes a mediator and it assigns it. This design means that all the subclasses automatically have access to the mediator through this definition of like this mediator that's being defined within that class. You can't accidentally reach out to a peer directly. So we have the chat room. This is the concrete mediator. This is the heart of the pattern. It implements the chat mediator. It maintains a registry of all the user objects through the method register user. And its send message format is where all the routing logic lives. So in this demo, the routing is going to be simple. The format to the message is just the sender name with a message, and we're just going to update the DOM. If this was like a real application, we'd have to put more access control, message filtering, broadcasting to multiple recipients, persistent to database, all without the colleagues need to know about it. So the mediator would own that complexity. Here we have the user component. The user component is the concrete colleague. It represents an individual chat participant. It extends the component and inherits the mediator reference. It wraps the user identity, and it has the send message method, which is incredibly simple. It just calls the mediator send message with passing in itself, the receiver, and the message. And that's the entire interaction. So the Alice's user component doesn't have any reference to Bob's user component. It doesn't know that Bob exists as an object. It just hands the message to the mediator and it steps back. So the chat room figures out everything else. This is how the mediator pattern is working together. So here we have here's the chat mediator interface. We just have that one method, send message. It takes the sender, the receiver, and the message string. This interface is the boundary between the colleagues and the mediator. Colleagues only depend on this interface. It doesn't depend on the chat room. That means that you could swap in different mediator implementations, one that filters profanity, one that logs to an audit trail, one that routes based on permissions without touching user component at all. So there's one interface, one method, but we can have multiple ways that we can implement it with, depending on what we're looking for, what we want. Here we have the component class, which is simple by design. It declares the protected mediator field. It's typed as the chat mediator, which is the interface. It's not the concrete class. The constructor just takes the mediator and it stores it. And if we look at the component, it doesn't define any abstract methods. That's left entirely to the subclasses. The only job that has is to guarantee that every colleague holds a mediator reference. The user component will call the hierarchy the super mediator in its own constructor, which triggers this single assignment. So it's simple, it's structural, and it's effective. If we look at the code for the chat room, we see that there's a users array as a participant registry. Constructor takes this node list of element. For the chat message containers, it directly references to the DOM. The register user adds a user to the registry. So the key method, again, we have is the send message. It receives the sender, the message, and it formats the display string. And it calls the private update message display. That method just puts a div onto every chat message element on the page, which is why both Alice and Bob's chat windows should update simultaneously when either one of those sends. So the chat room knows about the users and the DOM, but it doesn't know anything about the user component, and that's it. Looking at the code for the user component, it's super short. It extends the component. It stores a user, and it has a send message method. It delegates straight to the mediator. This is a patterns core discipline in the code. It's got 0 routing logic. It has 0 knowledge of its colleagues. If you had 100 user, every single user component instance would look just like this. The complexity will scale in the chat room, not within each one of these users. And that's the architectural win that this pattern delivers. the entry point to the index TypeScript. It shows how everything is connected. So we have one chat room instance that's connected together with the chat messages, the DOM elements. And then we have Alice and Bob. Those are the users. And then we register each of those users with the mediator. And then after that, we create the user components, both with Alice and Bob and those mediators as well. And then finally, we're able to delegate those messages to the mediator itself. When we call the component and the send message, it will actually call the mediator send message as well. Just like we have the example below, the Alice component sends message, it says, goes to Bob, and then it will route to Bob without having to call Bob itself. So it goes through the mediator, it never calls that component directly. The wiring is explicit, readable, and it's easy to extend. Here we have our demo here for the mediator pattern. This flow is under the assumption Alice is going to send a message to Bob. Right here, we send the message, goes over here. And what's happening is both user components are messaging each other through this mediator. Going through the code, we first get all of the chat messages. These are the divs here that we create as our quote unquote messages. We also create this chat room that connects the divs to this class. The chat messages are just the lists of these potential screens that we have here. Next, we're going to create the user. The user is just, it says interface, but it's more like an object that has the ID and the name here. And then we're going to register each of those users to the mediator. And through here, this is where we create that array, the user array, and we'll just push those users onto that array. And after that, we now create those user components, which the user component, we will create the user. We actually will encapsulate the user into its own class now instead of it being an object. And we will also make sure that the mediator for this user component will be allocated to this mediator. That means that once we call this send message method, we're using the mediator send message itself. And that goes on to this next part. So each of these connects to its own DOM event listener. But either way, no matter which one it is, we're going to call the send message. The user component will call send message here. And through the send message, we aren't directly messaging to the user itself. We're going through this mediator. The mediator send message actually will go through and call this method here, the update message display. We have the sender and then we have the receiver. The sender's name is, the sender is the person that's writing the message. Then we have the message here. This is going to be displayed on all the displays. In the beginning, we had these chat messages. These are technically the screens that we have here. For each of these messages, we're going to just create that message that will be displayed. And the most important thing to think about here is we have this array of users. Every component will have themselves as a user and also the mediator, which has already registered those users. When we send that message, we are going to just broadcast it to the display. So in that way, if one person is sending a message and it needs to connect to all of these, since we've already registered the users in the mediator, creating the user component, we can create this decoupling here so that any changes that have effect on each one of these shouldn't interfere with that core logic of sending that message. Use the mediator pattern when we have a complex web of object interactions. When the communication between components is complex enough to be of its concern, that could be just like GUI, dialogue boxes. That's like the biggest example we can think of, like text fields, checkboxes, buttons that respond to each other's changes. This can get really messy fast when they're wired directly. Another example that we have is chat systems like we had in this demo. That's a natural fit. Workflow engines, game AI, where multiple agents coordinate, event-driven UIs, and there's also any system where you want a centralized control over routing and the side effects. We don't want to use the mediator if we only have one or two or three objects that occasionally interact. This indirection adds more complexity than it removes. The biggest danger is that the mediator itself becomes this overarching object that has like so much control. It knows everything and knows everything about everyone. It makes complex decisions based on type checking, senders and receivers. So if your send message method is full of too many ifs, if the sender is this type, if the receiver is this type, then we've kind of overcomplicated this entire mediator pattern. And it might not need this pattern anymore. We might want to use something like an event bus or a more targeted design instead. And also performance is something I consider too. When we have this, it does loop through every single interaction through this central hub. So when we have this indirection, it can potentially compound as we use the mediator. Once we're having this mediator, we're consistently calling it, it's consistent broadcasting. So that's something to also consider as well. Here's 3 real-world analogies to give a better idea of the mediator pattern. The first one is air traffic control. The planes don't communicate directly with each other in the air. They all talk to the control tower. So the tower knows every plane's position, altitude, and flight plan. And it coordinates such as who lands first, who circles, who reroutes. So the tower is the mediator. The second one is if we think of like the stock exchange, the buyers and sellers don't really interact with each other. They both submit orders to the exchange, which matches them. So neither side knows the other end. And third one is like a Slack server. The client sends to the server fans out to the subscriber. So in each of these cases, adding a participant won't change the existing ones. Here, when comparing to some related patterns that we have, the first pattern that is confused with the mediator is the observer pattern. The observer is a one-to-many broadcast. The subject notifies all the subscribers with the same event, and they all react independently. The mediator is more selective. It can inspect who's sending to whom, and it can route differently for each combination. They're not mutually exclusive. A chat room mediator could internally use the observer to notify registered listeners. They're not two different things, so we can implement the mediator with the observer as well, just to summarize. The second one is the facade. The facade is a structural pattern that simplifies a complex subsystem with a single entry point, but the subsystem doesn't know the facade exists. The mediator is behavioral. Colleagues actively call the mediator. However, the facade is the one that just hides complexity. The mediator coordinates behavior between peers who would know about it. The 3 things to take away. The first one is the mediator centralized communication. Colleagues never call each other directly. All the traffic flows through this hub. The second one is the mediator owns the routing logic. So colleagues stay simple and completely ignorant of each other. And the third one is we want to watch out for this God object creep. If the mediator is branching on peer types, then we're going to have to reconsider the design. The pattern's power comes from discipline, one interface, one entry point, and one place to change when the communication logic evolves. That's the Mediator pattern. All the Typescript source code is in the description. You can try the GitHub repo. You can try to maybe like add another user, and you can try and create the user component and redistribute the chat room, and you can just play around with it as much as you can. So if that was helpful, if you can just hit like and subscribe, and I'll see you in the next one.